part A here. I can quickly graph now. I see it's a log graph. I know it's going to have an asymptote at x equals 0 and 1 comma 0 is a point. That's true of any base log graph. Now, because it's a base 2, I'm going to have the point 2 comma 1. And then I have the shape of my basic log graph. This is y equals log base 2 of x. And now I'm going to graph on a separate graph in green log base 2 of 2x minus 1. And if we recognize our parent function, I'm going to take out my highlighter here, and I'm going to highlight my parent function was log base 2 of x. So here, I'm going to highlight the log base 2 of x. Whatever is not highlighted is going to be a transformation. And we have to decide what's inside the function affects it horizontally, what's outside the function affects it vertically. So we can label these things. Can you see that that 2 is inside the logarithm? That makes it horizontal. Stretch, compression, reflection, translation. What is that one? What happens when you're multiplying? That'll be compression. You're going to multiply x by, because x is our liars? 1/2. Then the minus 1 here is outside. It's not inside the logarithm. If that minus 1 was inside the logarithm, they'd have a set of brackets there to make sure you knew. So this is going to be vertical. It's a translation. We are going to go 1 unit down. So could we graph this? Well, I could take my original blue points. I have 1 comma 0. I have 2 comma 1. And I have the asymptote at x equals 0. And I can take those blue points, apply the transformations, and find out where they are going to be on my green graph. Well, first, my x values get multiplied by 1/2. So a reminder of what we did in transformations unit, we always did our stretches and compressions first. So if I multiply by 1/2, this will be 1/2 comma 0, this will become 1 comma 0. Then I need to go 1 down. My x values now aren't changing. That'll be minus 1. Oops, I did a little typo. My y values didn't change. Minus 1, that'll be at 1 comma 0. So I can label these points. I've got 1 comma 0, 1/2 comma negative 1. What's going to happen to the asymptote? The only thing that's going to affect the asymptote is if you shift it left or right. We had no shifting left or right. It's going to stay exactly the same at x equals 0. Draw the shape of a logarithm towards your asymptote. Go through your points. They're very fussy on the exam. It is a requirement if you graph a logarithm that you must label the x-intercept. Even if the x-intercept isn't nice. In fact, I think it was last year's exam, either January or June, where the x-intercept was 1/9 comma 0. Not a very nice point, not one that you would normally label. So they actually, in order not to take off marks, they made part A of the question, find the x-intercept. And then graph it in part B, so hopefully you wouldn't forget. But they have a bunch of very interesting rules on the exam. Personally, I wish they would tell you that there's special rules in a question. Like if they really want you to label the x-intercept, how hard is it to remember to label the x-intercept? They could write that in instruction, and then they could find out, do you know how to do it or not? Not that you've memorized certain rules, right? Like you already have 10 E errors that you have to memorize to try to avoid. You have to know that if you have a decimal answer, how many decimal places do you have to do? 3 decimal places. If you do 2, they take a mark off, even though they don't say it in the question. For log graphs, you have to label x-intercepts. Polynomial graphs. So my rule is, instead of memorizing that each graph, which ones have to label and which ones don't, whenever possible, label your x-intercepts and y-intercepts. If it's not possible, if the value is something like, oh, the y-intercept was log base 2 of 37 over 5, I don't know how to label that, well, that's probably they're not going to take off points. But try to find your x-intercepts and y-intercepts for every graph and see if you can label them. Okay. So, identify the intercepts, we have it, 1, 0. And the equation of the asymptote, x equals 0. Domain and range, I'll just do those off to the side. So our domain is x is bigger than 0, and our range is everything. So I've got 2 more graphs for you to try on your own, and then I'll put up the answers. So I would like you, and you have space on page 400, to graph 4 log base 3 of x plus 1 minus 5. And I'll put up the answer in a second. Let's see how you did. Here's your basic graph, which I put the blue boxes around. So we got a vertical stretch by 4, 1 left and 5 down. If you look at where those points go, this is your new graph. So again, this question would expect you to label that x-intercept. And interestingly, the x-intercept of this one isn't the nicest to find. Like if I plug in 0 for y, and I solve for x, I would move my 5 over, divide by 4 to get my log by itself. Once you have a log by itself, you can change it to exponential form. The base is 3. The exponent would be 5/4 equals x plus 1, and so my x-intercept on this one is 3 to the 5/4 minus 1, 0. So pattern I've noticed on the exam is because they've made it a requirement to label the x-intercept for log graphs, they always make the transformations so that the x-intercept is a nicer point than this one. But you can always solve for an x-intercept by plugging in 0 for y. First I got the logarithm by itself by moving the 5 over and dividing by 4. Then I changed it from here to here is where I used the definition of the logarithm and changed from log form to exponential form. And by changing it to exponential form, now I can get the x by itself. So we're starting to see the beginning. Last couple of days we've just been learning log laws. and learning logs and manipulating them, we're starting to see where using those log laws helps us with graphing, helps us with solving equations. And the last example that I want you to try, with a natural log. And then once we've graphed this one, then we'll go over our identities test. So here's our basic log graph, ln of x. It's going to have 1, 0 and e, 1. We have to remember to put this in factored form from chapter 3. Whenever you have a horizontal stretch and a horizontal translation, you have to put it in factored form first. Maybe I'll put an extra set of big brackets around this. So I have a horizontal stretch by 2, and I have a horizontal translation 4 to the left. I can look at my original points. And with the point e, 1, when you multiply by 2, you get 2e, 2, and then when you subtract 4, you get 2e minus 4. Remember that e is about 2.7. So when you're estimating this in your head, 2 times 2.7 would be 5.4 minus 4, about 1.4. And here our asymptote changes because we go 4 to the left. If I wanted to label that x-intercept, I'd have to plug in 0 for y. So 0 equals 2 natural log I move the 3 over and divide by 2 to get the natural log by itself. And then once I have a single logarithm, the base is e, the exponent is 3/2. It would equal 1/2 x plus 2. I'll distribute that. Move the 2 over. Multiply everything by 2. And of course, they would never ask you on the exam for this kind of x-intercept, because it's not very nice. But it is a requirement to label all x-intercepts on log graphs. So I'll do it even though it's not a nice point. All right, you can circle questions 8, 9, 10, and 11.